Hey guys, welcome to the first episode of AEC Tech Talks. We are very excited today to have this episode. Thank you, Saurabh, for joining in as our first guest today. And thank you, my co-host Anisha. So my name is Gaurav Agrawal. I'm the owner of Agrawal Structural Consultants, and Anisha here is the owner of Neep Consulting Engineers. Today we have Saurabh Bulchandani here from Ramboll. He is the design engineer at Ramboll Delhi office, and he has quite a bit of experience in precast engineering from what I know. So Saurabh, I'll let you give your introduction.
Yeah. Thanks, Gaurav, for having me. It's really a great platform, and you guys are certainly going to do this for a noble cause. So I'm pretty excited for this. Just to brief you about my background, so I'm a structural engineer with almost like a decade year of experience. Currently working with Ramboll as a senior engineer, and I have been working in Indian projects and also in European projects mostly. And to tell about my overall experience, I have experience in working on concrete projects, precast, then steel. That's like the overall experience that
Nice.
I have. I have small experience on working on small timber structures as well. So that's the basic bit of it. Yeah. But today, I think as we have assembled, I think I'll be mostly taking you the challenges that we are facing or one faces while working on a precast structure. So I'll just brief you on that.
Sure, yeah, that sounds nice. So yeah, just you can just share your screen and just explain the project and whatever you are discussing, and we'll keep on asking you questions.
Sure, that would be really great. If even whenever you want to stop me, just let me know. We can take questions in between in that regard. No problem. Yeah.
All right, yeah, no
Yep.
worries.
So just to, I hope my screen is properly visible. Yeah. So just to brief, I think most you both already know in about precast structure, but in just for the our audience, what precast structures are is, let's say, in a typical cast in situ building, you have everything being done at site, right from the reinforcement placing, concrete, the formwork placing, and concreting. So as we mostly know that concrete takes some time to harden up and gain its strength. So there is a lot of time lost in a conventional cast in situ concrete projects. Whereas in a precast project, what exactly is done, that you are making each of the individual elements, be it wall panels, floor panels, on factory or a precast plant, and then you are bringing those to this site and making the connections. That's the typical crux of the precast structure that we have. So in a
Yes.
typical precast structure, the challenges that you come across, you can have multiple precast elements, right, from walls to the columns to beams, and even within there can be subcategories of the type that we are having, right? That is the basic funda. But still, if we want to understand how exactly structurally the things get complicated, we need to just dive into the detail that we have. So let's say you have a typical building which is, let's say, assumed to be of 6 story, right? And had it been a cast in situ building, you were able to do the erection at site. You had continuity of the rebar from wall elements or from column elements from top to bottom. Whereas in a precast system, you don't have that. So you need to attain that connectivity. So the very first challenge that you face in a structural in a structure like which is precast is the structural system. How do you are actually getting the loads down into the ground? What is going to be your structural system? Because see, since you have do not have cast in place concrete, you have lost the advantage of monolithicity. So you don't have the fixed connections anymore. Since you
Yeah.
do not have the fixed connection anymore, you have to plan your structural system such that it is basically working mostly in regard to the pinned connection. That's the very first challenge that you will face. And
Yep.
this has to be addressed at the very concept stage of the project rather than entering it into quite late. Maybe you have worked the entire structural system assuming that you will be able to attain a fixed connection between columns, but you are not able to do so because you do not have a monolithic connection between two columns. So that's the very first thing. So then you have connection constraints. Since uh, you have a certain limited type of connections that you can attain, even in terms of the load transfer, even let's say if it's only translational load, or only the forces needs to be transferred, not moments needs to be transferred. For those, you need to have a certain limitation, and those also needs to be established at the very beginning of the project, because that will determine the structural system you are going to go with. Then the next challenge becomes is the sizes of the element cannot be, since you are breaking your entire element. So let's say if you have a wall in the structural plan which is of 10 meters, so you cannot have that wall as 10 meters and going as one unit to to the structural site. The issue would be that you will not be able to transport it, you won't be able to lift it, you
Uh,
won't be able to cast it. So there are size
yeah.
constraint, and size
Yes.
constraint depend on basically three things. First, your plant capacity, how what exactly the tilting table which is uh, casting the precast wall or any slab element has the size. That sizing depends. Then the plant constraints that you have. Then you have transportation constraints, how long element can be transported on a particular vehicle. Further, let's say if you have a site-based plant, so in multiple precast project, it is like done, especially in India, since we don't have that high precast infrastructure, which is basically factories which can directly give you precast elements on order. People
Yeah.
try to set up site-based plants near their projects. So let's say they are having 12 towers being done in precast, they will set up a precast, they will get the machinery from a manufacturer, they will set up the plant right there itself, which will set up the which will save the transportation cost and also reduce the constraints that you have in terms of sizing related to transportation. Then you have constraint in regard to crane capacity. You cannot have as high or as low, as heavy as element possible, because in a project, let's say if you are having a certain plan, you will choose maybe multiple two three crane fixed crane locations where from which where you will place entirety of your element. So that gives you a certain capacity. So maximum could be 10 ton 15 ton depending on the crane location you are placing and how much is your element is going to be. So these are
Yeah.
the major constraint one uh, things and comes into play when we are working in a precast project. The last thing which I want to emphasize and which maybe might be overlooked by most of the person. So precast in India, or especially precast in seismic prone areas, are is slightly difficult to achieve, or has have had apprehension. Specific reason for that is we need to attain ductility. So
Uh,
for European countries or countries like Nordics, the seismic requirement is low. But whereas since India is a quite seismic prone country, the
mm,
beam column joints for us, even the shear walls go into the ductile zone and they cross the yield point, and because of the high forces that we get from the uh, because of the earthquake. So in that regard, what exactly happens, how do the connections perform, that is very very important. So you need to understand the load path, and also in regard to connections, whether they are ductile or not. Now there are multiple different type of connections coming up which are actually making this problem solve, and we are having grouted couplers being used in walls and columns, which are promising to give uh, some tension capacity or some fixity between the connections between two precast elements. So yeah, that's the point that I have one last point, but still in the meanwhile, if you guys have any questions, you can just ask me, and I can maybe we can take those. But there's one last point. I will just close with that. If there are no questions from you.
so yeah, regarding the connections, I
Yeah.
know that typically we do that slotted connections or the simply pinned connections in non-seismic regions.
Hmm.
But in seismic regions, we want that frame action or the fixity, as you
Yeah.
said.
Yeah.
So, is using dowels in the industry is it a prominent thing right now or not? Is that happening?
So dowel connections are used, especially for the vertical connections that we are having.
Yeah.
So
Yep.
let's assume a wall that you are having over here, and that's a precast wall.
Yep.
And let's say you have another wall coming on the top of it. So how typically a connection looks out to be is, let's say you will stop your vertical reinforcement in the precast element over here. There'll be
Yep.
dowel going up from this element
Mm.
to the element above. Similarly, there'll be more like larger spacing as compared to vertical bars, because you cannot provide dowels very close to each other. Yeah,
Yes.
that's a constraint.
Yeah.
Then
Yeah. Yeah.
in the above element, you can have you can have the corrugated sleeves, which are actually these. So you can have corrugated sleeves which will be
Ah. Yeah. Okay. Got it.
that corrugated sleeve will be filled in with the grout and the connection will be placed in. So this corrugated sleeve is already there in the precast element. But mind you,
Yeah.
even this connection does not give you that much of a fixed fixity so to say, because the connection
Okay.
capacity depends on multiple things. See, you are having a concrete element and there is a corrugated sheet put which has a capacity of load transfer with the concrete. Similarly, this once filled with the grout has a certain capacity. So it does not give you full tension capacity. In fact, the capacity of this is not right away governed by the tension capacity of this rebar. There is a lot of factor
Mhm.
going into play about
Yeah.
the connection that you have between the transfer between these two particular elements. Now, what I was talking about is the Groutek couplers, which promises a tension capacity. Those are slightly advanced couplers, which have been adapted in the industry. Yeah. So this is one type of connections that you can have. Yeah.
Okay. Okay. Yeah. You can continue. Yep. Got it.
Yeah. If there is no question from you, then the last point would be that is quite critical on uh, precast structure is robustness, which is how do you prevent progressive collapse to happen in your structure. That is very very critical. The thing is, structure like these are similar like steel structures. In typical conventional cast in situ structure, you don't need to worry about robustness much. I'm saying generally. Why so?
Mm.
Because you have a lot of reinforcement going through the joints. So even
Yeah.
let's say if a certain member collapse, or let's say if the load path is such, let's say assume this is a frame that you're having in a typical in situ arrangement, and let's say one of the columns or one of the beams goes off, you have a lot of reinforcement going through that, right? But assume
Yeah.
the same thing in precast. These elements are not not one, these are actually separate elements, and in
Yeah.
general for a conventional loading coming from the top or even from earthquake loading, you will not get much tension reextension in this particular area. So let's say if one of the column goes off in case of a like calamity or any other problem, the thing is this connection need to be designed for the tension, and those things will be only coming into picture when you are uh, properly checking the structure for the robustness of the alternate load path and providing the ties between the precast elements. So that is also quite critical in regard to precast, and that is one of the challenges that one faces.
Okay.
Yeah.
I see.
Yeah, I think this was mostly the points or the things that one should pay heed to while working on the precast structures. Yeah, mostly
Okay.
that. Yeah.
Saurabh, I have a
No.
very quick question.
Yeah.
So, with regards to robustness of the structure when you're checking, so how do you go about it? Like, do you figure out the, say, columns that have the maximum loading, and then you try to imagine a situation where they are no longer there or something like that? Like, can you elaborate on that?
Yeah. So Eurocode has a different philosophy, and Indian code has a different philosophy of that. But in general, in nutshell, I can explain you. There are two approaches which are followed to actually tackle the robustness. So the robustness strategies. There is something called as tying of the system, tying forces. So you basically tie different precast elements together. That is tie forces approach, and the next thing is key element approach. And the
Mm-hmm.
last which you are talking about is actually mostly combination of these two things work. What you were talking about is the notional removal of key element, or let's say figuring out if one of the column goes off, what is going to be the alternate load path. That is the most severe analysis as per the risk assess analysis. We do that. What tying for now? Let's take each one of these one by one. So tying forces means, let's say if for accidental case, if let's say uh, these for what force these two elements need to be connected for. Similarly, what force code recommends you a force that you need to take based on the dead load and the and the variable load that you're getting on the structure. What connection tie force you need to have between these two elements? That's the tie force you get. So you have horizontal ties and you have the vertical ties. If you adhere to it, you are basically ensuring the structure for the robustness as per the codal norms, right? Then you have key elements. So let's say the elements which are actually giving you a higher area to collapse. Let's say if a particular column falls and there'll be a loss of more than 15% of the floor area, that you need to design as a key element, and you need to amplify the design forces for that. That is
Okay.
the typical codal approach. The approach that you were talking about, which is basically notional removal of key element or any other, you will basically assess and see if let's say this particular column goes off, what is going to be the load path, and whether your structure has that additional factor of safety to take that, and how much of that factor of safety is. And then also you can assess the risk of losing this column. So you can basically have a probabilistic analysis of a particular structure, and accordingly you can amplify. That is the very last thing that we do. And we have like I have not done it thoroughly for a bigger structure, but that is the case we need to follow. Otherwise, using these two strategies, which is basically providing the tie forces and the key element design, suffice the requirement for robustness.
Yeah. Thank you.
Yeah. Yeah.
No, I definitely agree about the notional load path. I mean, in Indian context, when client is short on budget, I mean,
Mhm.
notional load path takes time as well, and
Yeah.
it would require you to increase the reinforcement or the concrete
Correct.
in the other elements.
Yeah. So it's I can tell you the code as well. It's IS 19
Ah,
15916. That's
10
the code
yeah.
you have for precast structures, and that there it gives you the requirement for tying forces and key element forces that you need to design. Yeah. And
Yes,
similar
yes.
in that we have in Euro code we have EN 9117. So yeah, that's a bit of a geeky stuff. Yeah, but that's the point. Yeah.
Oh yeah, and I mean in this precast thing, you can have a RCC thing and the pre-stress thing as well, right? So there
Yes.
are two different codes for them as well then.
Yes, that's true. So
Yeah.
we have IS 1343 for pre-stress
Yes.
structures, and otherwise 456 works as a for checks, but for pre-stress you need to follow that. Yep.
Yes. Yeah. And then in pre-stress you can have pre-stressing, pre-tensioning, and then
Post
post-tensioning. So
tensioning.
yeah,
So
yeah,
yeah,
Yeah.
I
lot
can.
of different types.
Yeah, so we can talk about it, but yeah, so
Yes.
but yeah, mostly in typical residential or commercial structures where repeatability is the objective we are going with, you will
Uh,
find pre-tensioning to be more adaptive, whereas structures like the rigid pavement of roads or
hmm.
bridges, these have post tensioning. Typical
Yeah.
buildings you will find to be pre-tensioned pre-stressing to be used in most of the cases, because you have to actually adapt the technology for that requirement, and which is slightly difficult to have, at least in the typical residential commercial buildings projects, I would say. Yeah.
Yeah. Definitely agree with that. Yeah. Yeah.
Yeah. Yeah. Yeah.
So Anisha, do
Yeah.
you have any questions?
Not at the moment.
Okay, yeah. So this was a great introduction, Saurabh. I think we can move forward to the project you wanted to discuss and the challenge. I wanted to say that you don't have to say the name or anything for the project,
Okay.
but
Uh,
any specific
got it.
scenario,
Got it.
anything you mentioned, that that's
Yeah.
helpful for us.
Yeah, so I can do that, no problem. So one of the recent projects that I think I have been part of, but what for a brief period, in regard to challenging precast projects. So I've been part of multiple projects in that regard, but in Indian context, and it is the 43-story precast building being built in Hyderabad. It's already we had around 8 towers of that, and it has 7 basements and 35 stories over that, 35 stories over that, and it was complete. It is completely precast right from the basement. It's just few of the retaining walls were cast in place, and it was very challenging because with 7 basements to plan those expansion joint around it, even the planning of retaining walls, especially in the areas where there are no buttresses, there are free 7 floor going walls. So I'll tell you in situation in that because since now we are talking about in the precast scenario. So let's say if there was a long retaining wall of around 100 meters which was to be planned, right? And we had slab connections for 7 basements, and then apart from that we had a certain area of the retaining wall, let's say around maybe 20 meters or so, which did not have a slab. So it had a cutout, basically.
Hmm.
So the challenge was that we had to introduce, although there was no internal wall planned, but we have to. So if we talk about the structural system of this particular retaining wall, it looked something like this. You have a base at the raft at the bottom, and then you have multiple 7 levels, and the structural system works as, so you can convert this particular panel, this particular system. After this, if let's say you have got the fixity, you can make the rest of the system above as precast. You can break them into the precast element. But let's say for these, it becomes very difficult if you try to make these elements precast. The problem is you do not have a buttress at the top, right? So if I take a section in this particular location, you have the basement draft over here, and then you don't have anything. And if you plan to break it, the problem becomes the out of plane stability. And to achieve that, we had to put buttresses, and after putting that buttresses, we had to do uh, part of that retaining wall was designed with this buttresses and precast elements, and to arrive at the connection forces between these two and between these two was the one of the challenging part that we had, because we had a very one common model. We had to make a part model and get the forces out of it along with the graph. So that was one of the challenge that I did face in a very large scale project that is there. And yeah, again, in terms of tower also there was a lot of complications. One problem that I just highlighted was for retaining walls in the non tower area. I was in the project for a very brief period. This was with Elematic back in 2022. Project is almost like in quite fast progress now. But yeah, quite challenging in the sense. Yeah.
Okay, no, definitely. So you mentioned about the model. What software did you use for this modeling?
So I can tell you, we had used ETAPS. In India,
Okay.
for doing precast structures, ETAPS is being used in most of the
Okay.
scenarios. In Nordics, we are preferring a tool called SuSoft Fem Design for precast. It is quite good tool for precast. Specifically, it gives you connection forces very easily, because in
Okay.
precast, for the one of the most important thing becomes is the how do you extract the connection forces, how easily you are able to control the stiffnesses. Because
Hmm.
see, in precast, this connection stiffness and this connection stiffness could be different, and depending on the connections that you are planning to give it, and accordingly the load transfer changes.
Hmm.
Okay.
So, sort of one quick question. So, you had to buttress this wall because it was slender. Was it the case?
It is actually the instability issue,
Out of
Anisha.
plane, you said?
Yeah,
Yeah.
if I don't have this altogether,
Hmm.
and if I take a precast element, so assume this is, see, again you cannot have a, I told you this is 20 meters, so even
Hmm.
horizontally you'll have to break the panels, right? And
Yes.
Correct.
horizontally also you need to break the panels till
Hmm.
this joint you have made this cast in place. But as you are moving above, we were planning to make it precast. In
Hmm.
this precast, it doesn't have a buttress. It is getting earth load, earth pressure from this side. It
Hmm.
doesn't have a support over here. It doesn't have a support over here. Further, it doesn't have, if I'm talking about an internal panel, it does not have a support on either of these sides as well. So it is
Hmm.
basically relying on the connections that it has with the adjacent member. That makes the structure unstable. You cannot right away rely upon that as a pin. So at least you have to have some buttress onto which you are pushing the compressive forces, right?
Hmm.
This,
Hmm.
because connection between these two you have is mostly happening either through the dowel action, or let's say even if you plan to give a shear key between two elements, which is quite uncommon, we
Hmm.
never do that. That is the only capacity that you will get between these two member, and the structural stability is dependent on that. And assume, like, imagine it for like 20-meter long wall, multiple panels with that, and you are having no connection, and with the height of 7 basements. So that's the issue.
I got it. So, you change the load path now. It goes to the
Yes.
buttress wall to the ground, right?
Yeah. So now for this, it becomes something like this. So it is,
Correct.
if this is like a counterfeit wall that we typically design in a retaining wall structure,
Yes.
something like
I
that.
was
Yeah.
thinking about that. Yeah, got
Yes,
it.
yes, yes, yes. It's the counterfeit wall that we design. Yeah, that's the
Mhm.
case. Yep.
So Saurabh, was this in a seismic zone?
Hyderabad, as you know, so
Okay.
it's,
Okay.
yeah, yeah.
Yeah. So regarding this horizontal connections, how did you connect the two walls? Because I remember I was doing one project for tilt-up walls, and we had trouble getting this wall connectors
So see,
very
here
interposed.
and tell you the again, you have to the details needs to be pretty monolithic on
Ah,
this case. So we basically, what we were doing, we were actually having a precast element like this. Then
okay.
our buttress wall is something like this. Buttress wall is having a rebar coming out from that, and this
Hmm.
part we are doing monolithically. So though it's precast, but this has to be done monolithically, because when you need to have fixity in this case, otherwise the
Yep.
system doesn't work in your case. So you have to have fixity. So in this, but if you're talking about those sort of connections which can just right away be dry connections, it will be difficult
Yeah.
to achieve that. Yeah. So it's
Yeah.
basically we were even between wall to wall joints we were planning to have, we were making it them fixed in some way or another. At least for the
Okay.
retaining wall. Above we could have gone with that. Similarly, it depends on your analytical model also. So let's say if
Mm-hmm.
in your analytical model, if wall is assumed to be taken as a single wall of 10 meters, in the analytical model it is taken to be 10 meters, and you are at the side you are breaking it into two, then you need to create that cast in place zone, and we need to do that. We had to do that in the structure, basically in
I
our case.
see.
Yeah. And for that we were basically increasing the dowel and casting the rest of the point, which increases the time certainly, but for a project of this scale we had to do that. Yeah.
Hmm.
Okay. So talking about the model, did you use cracked sections or uncracked sections?
So it's
Uh,
that used crack section analysis only, but for I can like, since tower model was not prepared by me, but we had used crack section analysis, I can tell you.
okay.
But for the retaining for this side of the structure, which is the non-tower area model, we didn't use the crack section analysis because it's mostly the gravity loads governed in
Ah,
that regard. Yeah.
I see.
And do you also do some kind of transportation analysis and lifting analysis for
Yes,
these kind
yes,
of, you
yes.
do?
You need to. Yes, so one needs to do that. In fact, if I can tell you the example of, let's say, how do you design a typical pre-stress member or a pre-stress hollow core design? So it is basically there are multiple tools to design it. But let's say I can tell you the crux of it. It doesn't matter what software is it. So you design it for erection, which is basically at the even before erection. I just called it. You design it for release, which is basically after
Hmm.
pre-stressing as it is being
Mm.
released. It has a, so mind you, concrete even in precast, if let's say it has been checked designed for M50 grade, finally at the time of release it will have very less, almost like M25 or M20 capacity at the release, right? So you'll have to
Yeah.
ensure the pre-camber it is creating at the it will create more pre-camber because concrete doesn't have that capacity in the early stage, so you need to check for
Yeah.
releases as well.
Yep.
And that's one thing. Then for storage, if let's say one of the major challenge then one if you will face if a particular member is kept for storage for 100 days, or let's say for a longer period. Let's say typically if the designer has designed for only 7 days and you have kept this the element for in storage for, let's say, uh, thrice that time or four times that time, what would happen? Since designer had assumed that after 7 days of period there'll be more load onto it, or after transportation there'll be more load onto it, there'll be upward deflection forming because of the pre-stressing of the strand. So you need to pay that into heat. And also we have multiple time come across this type of problem where a precast element were left for storage and they started to see upward deflection in those. Yeah, so that's one thing. Then you need to design on how the storage are being done, up to what spacing they are placing the support. Then for the transport, and also for transport we amplify the forces with a certain dynamic factor. Then you have erections where you have started to have cast in place screed over these uh, uh, over these precast panels, and as
Yeah.
the time passes it gains the strength, and eventually you need to check this for your final composite section along with precast and the hardened topping over it. Yeah,
Hmm.
so that's
Okay.
something like that. Yeah, so you need to
So,
check it, and similarly you need to check for lifting as well for all the types of element, and there are various ways of lifting different type of precast
hmm.
elements.
Yeah, so you would have certain number of fixing points, like lifting points, okay, at
Yes,
these
yes.
locations, this particular thing.
Yes, 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 yes. So for see that also varies. If let's say typical hollow core decks that we have are lifted using chain lifting, so they do not have a point. It's typically 1.2 meter wide. They have a groove like this, and using that groove, they are lifted.
Hmm.
So they can have a chain or belt sort of lifting. There are no lifting points on that. Whereas a typical, let's say you are having a solid precast panel with maybe pre-stressed or even reinforced bar, there you will have lifting hooks placed, four lifting hooks placed,
Hmm.
depending on the center of gravity or the shape of the element that you're having. Typically for sandwich panels or the tilting walls, which Gaurav was just mentioning, you will have two lifting points to lift those. Yeah, something
Yeah.
like that. Typically on L by 5 from both the sides. Yeah, so
Yeah.
something
Hmm.
like that. Yeah.
So
Okay.
all
I
these
think.
exercises are done in ETABS.
No, we don't do. So you don't need to do these checks in ETABS. You can have a small Excel sheet built on your own, or let's say uh, maybe a small program you can run, but you don't need to do that in ETAPS specifically. Why it has to be most, because it's a bigger tool. You're using it for the
Yeah.
global design. For these element design and check, you can do it like uh, by an hand calc or maybe manually. And for most of the precast manufacturers that we mostly work with in Nordics, they have these standards quite in place, so that for how much element of weight and for how much element size, what reinforcement do they generally place. So unless you have a very specific requirement, you need to do that. But otherwise, for a typical case, even if I need to do the calculation, I'll do a hand calc or Excel sheet based mm, calculation I can prepare. So
Sounds.
Yeah, I think in US codes there is a maximum lifting stress number that you have to take
hmm
care of to
yes,
decide the number of lifting points,
okay,
something like that. I remember.
okay.
Yeah, I think that's for the design part. Let's say if you are on the site, what advice would you give to, the site inspector or the structural engineer visiting the site if this precast system is
Mm.
getting.
I think the very first thing in the foundation part, I would say the dowel layout needs to match accurately. There is
Okay.
usually for precast we go about with a 20 tolerance, but even that can be difficult. So let's say the very first thing and the very thing that can go wrong is, let's say after erection your foundation was cast and you had a multiple dowel layout plan, and if the dowel layout plan is not given correctly, all your element is not going to fix, and it is going to be a huge loss. And in precast you cannot avoid you cannot afford that. Losing one element is a lot of loss, not in terms of concrete or material or the time it has underwent to
Hmm.
do that element. And let's say if you're trying to get, so have repeatability in the system in that regard. And also if one is at the site, he first needs to ensure the dowel layouts are as accurate, and even the person who's doing the BIM or the engineering part of it, or the person who's sending the drawings to the site, has to ensure that the dowel layout plan is as accurate as it is, because this can be corrected, but even once they are placed, the placing of the element will not be possible.
I
That's
see.
one thing. And yeah, I think apart from that, I'll say you'll have to ensure the connections are done properly. We have seen pretty bad sites where welded plate connections are not done properly. You need to ensure they are getting connected. Even if you are providing a wire loop connections, the wire loops needs to cross each other at least as a specific point, so that it comes into action when needed. Although there is very less load transfer happening through wire loops connection, but at least we have seen even the wire loops are not getting opened in some of the cases, which creates a problem in that long run.
I
So
see.
yeah, I think there is a lot of checks that you need to do in regard to connections, in regard to the all the interactions that you have between precast element and precast to in situ elements.
Yeah. Oh, I see.
So, sort
Yeah.
of like I'm hearing you need to do a lot of pre-planning and
Yeah.
more detailed drawing creation, etc., to get everything right on site.
Yeah.
So, when we compare this to conventional concrete construction or design,
hmm
then how does it compare in terms of timeline, and for the owner, how does it compare in terms of cost? If you can share something about that.
See, there'll be maybe more time spent on designing, but it's not like that. But you need a slightly skilled engineers and skilled modelers to do that. See, one thing that is in the design, but also you need to use BIM. I have seen people who have delivered good precast project based in 2D only, but you need to have a far better vision of foreseeing a problem if you're working in 2D. I know people who have worked in 2D precast and delivered like quite spectacular work, but you need to have that vision and with clarity and any foreseeing of problem. But nowadays I think BIM becomes an essentiality, so that's a cost, software cost adding to your project. Maybe in a typical Indian mindset you might go with a typical 2D drawings only and do not use BIM, although that shift is already happening, that people are using BIM more and more. But still I would say that this particular part is still left, so that will be a additional software cost add. And also you need slightly skilled engineers, skilled BIM professionals to work upon it. That's one cost add. In terms of timeline, maybe you spend 1.5x in the design, let's say if you are spending x, but you save a lot in terms of actual being done at site in terms of timeline, also in terms of cost. So yeah, that like in cost, it won't be that drastic reduction,
Hmm.
but it will be a lot in terms of time that you have. So you are basically saving up. Let's say you will be able to deliver early, no. So let's say for a project which is, let's say, meant to be delivered with 25 crore, and you are able to get the building early, you're able to sell early, you're able to get the resale of that particular value early. That's
Hmm.
one builder mindset that you need to think about. In terms of
Right.
costing, incurred costing, it might go up, but the payback period will be faster, so
Hmm.
you are easy to make money in that sense. Yeah.
Hmm.
that-
So overall, you're saying that it's a better option as compared to conventional overall.
yes, yes, it is, and that's one thing. And also, if you go in typical in India, that's one thing. But let's say if you're going with a Nordic country mindset, what
Hmm.
exactly happens, or a European country or even US, running a site itself becomes a cost. You need to
Correct.
comply to the even in India also, but even outside, there are multiple safety norms that you need to comply with, health and
Hmm.
safety norms. There is
Yeah.
certainly cost, for a per day cost. The site is very very huge,
Yeah.
and that basically supersedes the cost of a some material save or some. So that's the mindset or mind shift that they have, is basically you will see that there is a lot of saving being done in terms of the running of the site. So if you are reducing the construction time, you are basically saving cost, but maybe that's not the case here in India directly being seen. So that is the case.
Yeah, I think quality is much better because this is a controlled environment in which it is being created.
Yes,
But then,
yes,
like labor, I think in India is cheaper. That's why the shift has
yes,
been slower.
yes, yes, that's true. So we value more material more, and they value maybe labor and the ease of construction more
Yeah.
in terms of time. Yeah. That's the case. Yeah.
Okay. Yeah, I think, Anisha, if you have any questions, because we are right on time here.
I think Saurabh has very well explained
Yeah, same
everything.
here. Same here. Yep.
And I'm feeling more knowledgeable now in terms of like precast
Thanks.
structure.
Yeah.
No, definitely. Yeah, I mean, just to conclude, I think from what I got, connections, connections, and connections while designing precast. So yeah, I think that's that's all we have. Sort of, if you want to add anything more.
No, I think mostly you summarized it well, and it's quite good. And thanks for having me. I tried to like just put up a topic which I felt was close to me, and I just wanted to explain. But yeah, it was really nice connecting with you guys, and yeah, would like to be in touch in future.
No,
Same.
definitely. Yeah, we'll get you here on more topics. Whatever whatever comes up. So yeah, thanks for giving your time, and it was a pleasure talking to you.
Yes,
We'll update you about the recordings.
yeah, sure. Likewise. Thank you.
Thank you so much,
Thank
Saurabh.
you.
Bye, guys.
Thank
Bye.
you. Bye. Have a good day.